So we're going to go ahead and start this. Most of this will be from yesterday. This chart here, inverse trigonometric functions. Again, we're going to start with the pre-calc or advanced math stuff. Tomorrow we're going to get into the derivatives of it, but we've been writing them down 2 days now. So here's the deal. It says y equals arc sine x, that's inverse sine x. IFF stands for if and only if. Sine of y equals x. So we wrote it like this yesterday. We said y equals inverse sine of x, and then, well, actually, let's write it like we did yesterday. That's theta. Then the sine of theta is x. Okay, so that's just the equivalent way. And then here's the main three, and I showed you yesterday how you do the other three, but it's essentially this, just do the reciprocals. Inverse sine is your negative pi over 2 to pi over 2. Inverse cosine is 0 to pi. Inverse tangent is negative pi over 2 to pi over 2. And we did the graphs already. Okay? So let's do example 1. It says in letter A, arc sine negative 1/2. So this means the sine of what angle is negative 1/2. So let me give you a head start. Finish this one and do B, C, and D. I will tell you letter D is not unit circle. D is going to require a calculator. All right, letter D, this is not unit circle, so all you're going to do, check your mode on the calculator. Typically, we do inverse trig values in radians, and if you notice, this is all radians. So you want to try to work in radians here. So check your mode, and you just press second sine 0.3, and you're going to get 0.305, okay? All right, then there's a note. Inverse functions have the property that f of f inverse of x, that's the composition of functions, equals x, and f inverse of f of x equals x. When applying these properties to inverse functions, remember that the trigonometric functions have inverse functions only in the restricted domains. For x values outside these domains, these two properties do not hold. For example, if I want to do arc sine of pi, it's not pi. What you're going to do, and I'm going to rewrite it too. Let's say I have inverse sine of pi. Well, the sine of pi is 0, isn't it? If I think about my unit circle, okay, the sine of pi is 0. Then inverse sine of 0 is the sine of theta equals 0, but it's between negative pi over 2 and pi over 2. So it's 0. Okay, so be careful with those. They traditionally knock each other out, inverse sine and sine. However, you have to stay in the restricted domain. So what I do is instead of just trying to cancel them, I work them out, and then I won't make a mistake. Okay, so just be careful with that. All right, continuing on. Properties. So here's the deal. If I take the sine of inverse sine of x, it's x, and inverse sine of sine y is essentially y. Just check the restricted domains. And then if I do tangent of inverse tangent of x is x, and inverse tangent of tangent y is y. And cosine of inverse cosine of x is x, and inverse cosine of cosine y is y. So essentially we're saying they knock each other out. Okay, they cancel each other. So that's like saying the square root of x squared is x. Okay, inverse sine of sine, they should undo each other, but we just have to be careful when dealing with that inverse sine, inverse tangent, inverse cosine. Okay, so just be careful with that. All right, we're going to do example 2 and example 3 today. And then stop at that point and then finish it tomorrow. Example 2 says, well, how do you solve an equation like this? If it says arctan 2x minus 3 equals pi over 4. Well, just like we did before, this is really saying the tangent of pi over 4 equals 2x minus 3. You get that? That if we said, if I just had arctan of something, we set it equal to theta, and you took tangent of that theta equals the inside. Well, what's the tangent of pi over 4? 1. So, well, that was convenient, wasn't it? So I get 1 equals 2x minus 3. Add 3 to both sides, and x is 2. So really, it's not a big deal. So you would do this with arc sine or arc cosine as well. Okay, just rewrite it. All right, example 3 says using right triangles. If you're given y equals arc sine x, find cosine y. So again, you did this in advanced math last year. Let's rewrite this. Okay, this is actually the sine of y equals x. And then we're going to use SOHCAHTOA in a right triangle. So if I have sine of y, okay, that means y is the angle, and x we can rewrite as x over 1. Okay, so what I did is I rewrote y equals arc sine x as the sine of y equals x. Well, x is equivalent to x over 1, and I'm going to use SOHCAHTOA. Y is the angle, okay, the sine of an angle. So y is the angle, x over 1, opposite over hypotenuse. So then we can find the missing side by using Pythagorean theorem. X squared plus, let's call it question mark squared, equals 1 squared. That's 1 minus x squared, so that missing side is the square root of that. Now, the question was, or the problem says, find the cosine of y. Well, the cosine from SOHCAHTOA, cosine is adjacent over hypotenuse. So I want the cosine of y is the square root of 1 minus x squared over 1, or just the square root of 1 minus x squared. All right, because that one's a little tricky, let's try one more of those. In letter B, it says given y equals arc secant, square root 5 over 2, find the tangent of y. Well, let's rewrite this and say that's the secant of y equals the square root of 5 over 2. Now, you can either do it with secant, which I'm going to do, or you could rewrite that as cosine and make it 2 over square root 5. You get that? You can just flip it. But I don't see any reason to as long as we can handle this. Secant is hypotenuse over adjacent. So the square root of 5 is the hypotenuse, 2 is the adjacent. Go ahead and find the missing side using Pythagorean theorem. You can call it A, you can call it B, you can call it another letter, whatever you want.